7.3 is what we're going to be discussing, logarithms and logarithmic functions. Different ways of writing, going from exponential, which we've already covered, into now log form, which is right here. I kind of looked at the pieces and where they go from one to the inverse of the other. So exponential and logs are inverses of each other. If you notice, the b is the base, and that's where it belongs there as the base of the log. The a, which is the answer, is right after the base, because you're looking at the base, log base b of a is x, and then x would then become the inverse of what we're looking for. So the log and the exponent answer. So that's how you would transfer one to the other. And then I wrote there how you read it. On this slide, let's take a look at writing exponential equations in log form and vice versa. So let's take a look at a problem such as the log, let's see here, base 9 of 3 is equal to 1/2. So that's what it is in log form, and we want to change it to exponential. Well, we just take the base to the 1/2 power is 3, and that's how you would rewrite an exponential form. Let's say I had exponential form to be 2 to the 3rd is 8, and I wanted to change that into log form. Well, then I do the log base 2 of 8 is 3. Let's do the log with a base of a 1/3 of 1/9 is 2. Let's change that to exponential form. So we always start with the base. So 1/3 to the 2nd power is equal to 1/9. Let's do the log of x. Log base x of 1 equals 0. So x to the 0 power is 1. Anything to the 0 power is 1. Okay, so that's how you just transform one to another. Here we're going to look at evaluating. So we find the unknown. If you notice, this is supposed to be a log of base 5 of 25. We're going to go ahead and rewrite this. So log base 5 of 25 is something, and we got to find that unknown. So we go ahead and rewrite it in exponential form. 5 to the x is equal to 25. Change the base, or if you already know, 5 squared is 25. But the reason it works is because we remember from the last time we have to have the same base. So then therefore you set your exponents equal to each other. Okay. Let's look at another one. Here we have log base 5 of 1 over 625. So we rewrite it. Log base 5 of 1 over 625 is equal to x. So 5 to the x is equal to 1625. Well, need some base, and 5 seems legit, so let's go ahead and see 5 to the x will stay, but the 625 is going to be a negative. Since it was a fraction, we got to flip it back around. So I look at my calculator and I say, okay, well, what 5 times what itself, how many times will give me 625? Well, I noticed 5 to the 4th gives me 625, and then I invert it by putting a negative there. So therefore my answer ends up being x is equal to -4. Let's go ahead and graph this on the next slide. On this slide here, we're graphing the y equals, or f of x equals log base b of x. Once again, that's supposed to be a base b. And we remember that our inverse is b of x equals y. So we look at the parent graph, The parent graph of a log is 1, 0, and then another point would be the base and 1. If you remember from exponential, it was reverse, because in inverse we reverse the x and the y coordinates. So we want to go ahead and take a look at the parent graph of a log function. So with the parent graph, it's going to be something like 1, 0, and then the base, some number, and 1. And the base will be given to us. And then we draw a smooth curve. So there's what a parent graph would look like, knowing that our asymptote is going to be, in this case, it's going to be x equals 0 is our asymptote. So it will never cross that axis. It'll get close to that axis, but it won't cross it with the parent graph. The domain is negative, nope, it's 0 for my parent graph to infinity, because it can't cross this side of my asymptote. So it's 0, and then of course all the way to positive infinity. And then my range is everything, anything below the graph, that's why it goes down here, and then anything up higher. So negative infinity and positive infinity. Let's take a look at an example with our next slide. At the top here we have f of x equals the log base 3 of x plus 1 minus 4. So in drawing the parent graph, we have 1, 0, which is always a constant, and then the base is 3, 1. And what we're going to do is we're going to transform these points, we're going to transform them. And before I transform them, let me plot these points, 1, 0, 3, 1. So there is my graph, and up, starting with my y-axis going upward, like the previous parent graph. But then, like I said, we're going to transform this. We're going to go to the x, we're going to go to the left on the x-axis once, and then the y value, we're going to go down with the y values 4 times. So each of these points go to the left 1, and then 1, 2, 3, 4, left 1, and then 1, 2, 3, 4. So it gets real close to the asymptote. In this case, the asymptote is changed to negative 1. So x equals negative 1 is my asymptote, which helps me with my domain. The domain is from negative 1 to positive infinity. My range is negative infinity to positive infinity. The next example, let's start off with our parent graph. So in the parent graph, we have 1, 0, and then we have the base is 5. And I forgot to write, let me rewrite this equation. Log base 5 of x plus 2. There you go, I feel better now. And then so I have 5 and 1. But we have an extra part to this. It's the a part, which is in the front. So we need to multiply everything by negative 1 because it's in the front. It's going to help us take our graph and reflect it. And so let's see here. If I multiply the y value by the a value, so 0 times negative 1 is negative 1. 1 times negative, my bad. Let me erase that. If I can find my eraser. Okay. I guess it doesn't want me to erase it. Very weird. Well, that's supposed to be a 0 because 1 times anything is 0. 1 times negative 1 is negative 1. All right, so now what we're going to do is we're going to plot those points as our starter. So 1, 0, and then 5, 1, 2, 3, 4, 5, negative 1. So our curve is going downward from the y-axis down, curving, but I need to now transform all of these up 2. So transform my y values up 2. Nothing to do with my x values because x is just, there's nothing, with the associated with the x, there's just plain x. So up 2, 1, 2, 1, 2. So I didn't move anywhere my asymptote, so there is my downward curve. My asymptote is still at x equals 0. So I just reflected on the x-axis. Okay, so those are the types of graphs. Keep in mind it's just also a review of the transformations we've been doing. So you may have to also look at the videos from those transformations. Have a wonderful day, guys.